Welcome back. All right, so now you saw we had just finished the Excel, unless you're seeing it in different order. But I wanted to go back and just remind you the form that we had finally put it into, which was an inequality form that we had done during my lecture on the diet problem. Okay, so hopefully you have watched the lecture on the diet problem before even running through the solvers that we're playing with. So I just want you to refresh your memory that A hat was the big matrix that came out of Excel, but it was actually the transpose of the matrix, if you think about it. Because what happened is that A hat, each row is a different nutrient, and each column from the theory lecture, each column is food, okay, the item food. So this is really the nutrient 1 in food 1, nutrient 1 in food 2. But if you remember in Excel, it was actually the opposite. It was the transpose of this. So if you look on Excel, the rows were the food and the columns were the nutrient. But when you do A hat times X, then X is the food, so A hat, the columns of A hat have to be the foods. Otherwise, you can't multiply those together. So let's just remember that we're going to use the transpose of the Excel data when multiplying it AX like this. Okay, so we had A hat minus A hat, and that's for the upper bound, the lower bound in inequality, or the less than or equal to form. And then, of course, the bottom part of the A and the B were, because we want to make sure that Matlab knows that each of the food, the number of servings per food, have to be greater than 0. Okay? Because otherwise, if you allowed negative, well, you might be able to just minimize it to negative infinity to really minimize the cost, do negative food, but that doesn't even make sense. So this is a very important constraint to tell the solver. Okay? All right, so let's go to Matlab. So here, here's an M script, or an M file. You can see here I like to clear all variables in the workspace. I like to clear the console, and I like to close all figures. Sort of a standard beginning I like to do. And then here's just a cell array with the names of the first food and so on down to the 64th food, which was the bean bacon soup. Now, of course, if it's not bacon, I've already said that once. Could be something else, but let's go with it. And this is just so I can pull out the name later. Okay, and then I have a cell array of the names of the nutrients in their order. And I guess I should say a little bit, when I say cell array, it's different than a matrix or a vector. It's got the curly bracket rather than the square bracket. And I just want to say that, we don't really have the time to go into every detail of Matlab. This is not a Matlab course. So you don't even have to use Matlab to solve these problems. As you saw, we can solve it in Excel, or you can use Python. So if something's new to you, when you see something, you might want to just either do some Matlab tutorials, things like that. Okay, so I'm just going to assume that you either have some work to do if you want to use Matlab to learn it, do some tutorials, or that you already know it. Okay, so here's the important matrix. This is the A hat matrix, but this is actually the transpose of the A hat matrix. Meaning that, let's look at it. If I go to the workspace, you can see it over here, or you can also type whos. So you can see that the matrix is 64 by 11. So it's actually the transpose of what we want it to be. We want A hat to be 11 by 64. So just remember that, because we're going to transpose this matrix when we put it into that larger A is less than or equal to B. Right? And of course the cost has to be 64 long. the names of the foods is 64 long. The maximum and minimum bounds on the nutrients have to be 11 long, and of course the names, which are cells, are 11 long. Okay, all right. So if we keep scrolling down, we see here's our cost. All right, so that's in a vector form, and that's also in a column form. So as you can see, cost is 64 by 1, so it's a column, and we'll need to transpose it, and when we multiply it by the variables to get the cost. So it's C transpose X, inner product, that I had mentioned before in the intro to some of the linear algebra that we were talking about in this class. And then, of course, you have your list of maximum and minimum nutrients, also in column 4. Okay, so really I just took the Excel data and just put it into Matlab matrix and vector form. All right. So now we just need to solve it. So really, the nice thing is with Matlab, you can just go help linprog. We're going to use the function linprog, and you do need to have the optimization toolbox to be able to get it. So there's a few different forms, but this is the most basic form. You have minimize C transpose X, or in this case they have F, subject to AX is less than or equal to B. So that's our inequality form. So let's build our A, B, and we know our C. So let's go ahead and build it, and let's use this to solve it. Okay? So I'm going to come down here, and I'm going to say, and we're going to do it a few different ways, but let's do linprog. Now we know what the F is, or the C. It's cost. So it's cost transpose times X will give us the cost. Then our A, I'm going to say A big, and then I'm going to say B big. B big. All right. Let me define that. I'll leave it open. So A big equals, well, it equals to our amount, and if I hit tab, it should pop up. And then that's transpose. So that little apostrophe is a simple way to do transpose, or you could also type in actual transpose. Okay, so I'm gonna use the apostrophe, so keep an eye on that. All right, so it's A transpose, A hat, which is A hat, and then minus A hat. Okay, and then of course, sorry, this is the next. I have to put a semicolon to go the next columns, another semicolon to go the next, and then it's the identity. And it is the identity. It's a 64 by 64. So I can just type either 64, or I can also say length of cost will also give me 64. All right. And of course, if you just put in one number in I, then you get of course the identity, which is a square matrix in this case. All right. So I'm going to do that, and the semicolon prevents it from echoing on the screen. Okay, and of course B big was equal to, so the upper bound, which is the max nutrients, then minus the min nutrients, and then the zero vector, so a zeros, which was 64 long, or length of cost, long, and then 1 wide. All right, so and then plug it in, you should get the solution. So let's run it. Oh, I got an error. Let's see what the error is. Be big. Oh, be big. I'm sure one of you already saw that. Okay, solving. I made a mistake somewhere. Hold on, let me double check. Pause for a second. Okay, yeah, I just had to find, I forgot this negative here in front of the identity. So if I go back, you have A hat minus I, and I forgot that minus. So now running it, come back, and here's our solution. And as you can see, here we have, if you look, these numbers actually turn out to be exactly the same. Now let me double check what these correspond to, and hopefully again they correspond to popcorn and peanut butter, and they should, right? And this is the code that I did to do that. So I look for anything that's greater than some small number. I want to say greater than 0, but due to possible machine error, all of them could be greater than 0. So I'm looking for greater than a small number. Okay, and then I find those indices, and then I go through and I just display those indices. That's all from the names of the foods. Right, they should correspond. So if I run it, come down here, and as you can see, so the last number that's non-zero, which was this, was peanut butter, popcorn. Actually, I see baked potato, and I think I thought in Excel we had tofu. So maybe I just read that wrong. Let's see, where's tofu? I guess baked potato and tofu are close together. So actually, I probably read that wrong off the Excel. All right. So and then finally, you know, there are many. If you just go help Lynn Prog, I could actually solve this a few different ways. So for example, I don't actually need. So look, I have a lower bound and an upper bound. Okay, sorry, this is on the this is on the states. Okay, so this is on the foods. So I could just have a lower bound of 0 and not have to include the identity. All right. So for example, I don't need this bottom section here because I can just tell Matlab or Lynn Prog that my variables are greater than 0 by using this LB. Okay, so I could do that, and maybe let's try that real quick. And then also, for example, you saw how we can change equality into inequality form, but in Lynn Prog, you actually don't even need to convert them. You can leave equality equations in equality form and inequality equations inequality form, and lower and upper bounds on the variables in this form. Okay, so that's another way to use Lynn Prog, and this is an initial condition for the algorithm. Remember, this is an iterative algorithm, so this is a way for you to set the initial guess, but you don't need to use that. So let's try that. So I'm going to get rid of the zeros. Oops. I'm going to get rid of this section, the bottom section, and I'm going to get rid of this bottom section. Okay, and then I'm going to do comma. There, I have no equality. So it's blank, blank, and then my lower bound on my states are zeros. So if I do zeros, and I have to do it for every state, so that's length of cost, which was 64. Yeah. Okay, and that's my lower bound, as Matlab shows you. All right, but let's double check that this code works, just to make sure that it happens so fast. Yep, it's okay. So here you have an identical solution. All right, so those are a few different ways to use the Lynn Prog, and of course you can go help Lynn Prog and learn a little bit more about it. Okay, so now the next thing I want to do is use a very nice tool called CVX, free tool actually. So you need MATLAB, but you don't need the optimization toolbox. So we'll come to that next.